Hello everyone, welcome to Vision Tech Solutions channel. In this video, I'm gonna show you how to configure NAT or Network Address Translation. But first of all, I'll give you an introduction about what is NAT and why we need to use it in our networks. So if you look at this picture, you can see that we have a user who wants to connect to the internet, and he's sitting in a LAN with the private IP address. In order to connect to the internet or use the internet, this user needs to use a routable IP address or the public IP address. And currently it has assigned a kind of private IP address. So this router needs to translate the private IP address that this user is using into a public IP address that can be routable over the internet, so this user can have access to the internet. So in this topology, there is one-to-one mapping between the private IP and the public IP. If we can see that 10.0.0.9 is a public IP address this user is using on its LAN, and then this router will translate it to the public IP address. And when we receive the packet, of course, it will translate it back to the public IP. So in this scenario, we can see that we have one-to-one mapping. So it means for every user that is using a private IP, we need a one public IP, but it is not feasible or scalable. So to resolve this problem, we use something called PAT or port address translation. We will have a number of users, so all they use one public IP address but different ports. That is called port address translation. So in this case, or sometimes we call it the NAT overload. So a number of private IP addresses will use the same public IP address but different ports. So in this case, we only need one public. We don't need one-to-one mapping. So and of course there are some terminologies with regard to the network address translation, like the inside local, inside global, outside local, and outside global. So the inside local, we use this terminology for the private IP addresses, and global, inside global, for the public IP addresses that are replaced by the router. So this is the inside local, this is the private, and inside global is the public IP address that is that this router uses to replace the private IP address. And the outside host address can also be changed with NAT, and the outside global address represents the outside host with a public IP address that can be used for routing in the public internet. This is the outside global, and the outside local address is a private IP address of the external device as it is referenced to by devices on the local network. So so this device, which is outside, it also has one private IP address which is seen by our network. This is called the outside local address. And we have, of course, different type of the NAT translation. So as I said, we have a static NAT, one-to-one mapping. We have dynamic NAT, which we can use, for example, a range of public IP addresses. And we have NAT overload, which is this one, which shows the public one private IP address going to one public IP address, but with different ports. Okay, let's jump into the topology that we are going to work on. So in this topology, as you can see, we have three routers, router R1, R2, R3, and we have one R4, which is our edge router going to the ISP. So what we want to do, our task is to configure R4 to translate packets sourced from the Ethernet interfaces of R1, R2, and R3. So our goal is to, when this router receives the packets from the Ethernet interfaces, I'm gonna show you the IP addresses, it will translate them to this IP address, the IP address of 155.1.108.1, and then send. So every packet which is received by R4 will be translated to this IP address. Now let's see how we can do this configuration. Currently, if I go to router 1, and because the IP addresses are been set, and we have also OSPF running between all these routers, so we have 155.1.108.2 is the IP address of this interface, and we have also the loopback interface. Let's go to ISP and check the IP addresses. Show IP int brief. So the loopback IP address is 150.1.108.2. And what I'm gonna do from router 1, we haven't set up the NAT yet, so let's see if we want to ping the loopback IP 150. Let's check again. .1.108.2. 1.108.2. Okay, we can ping. Now I want to show you something. If I would debug IP ICMP, so the debug is on, because at the same time I want to show you the debug. So if I ping the loopback IP address of the ISP, you can see that the source is coming from 155.1.1. Actually, the destination is this R1's Ethernet interface. Now if I show IP int brief, so this is 155.1.1.1. So okay, because it is sending the packet back, it shows the destination, but it means that the packet came from this source and going to this destination. When it is sending back, it is sourcing from its loopback interface going to this interface. So it is showing that it is coming from 155.1.1.1. But what we want to do, we don't want this IP. We want router R4 to translate these IPs into 155.1.108.1. So we have to enable NAT on R4. So what I'm gonna do, I will enable NAT. So int gig, so this is gig 00, this one is gig 00, and this is gig 01. So this is NAT inside and this is NAT outside. 0 IP NAT inside, and int gig 01 facing the ISP is IP NAT outside. Now I have to create an access list to allow the IPs that are coming from the Ethernet interfaces of R1, R2, and R3. IP access list standard. I call it internal, and I will permit 155.1 because all these interfaces are within this subnet 155.1.1. So for router 1 is .1, for router 2 is .2, and for router 3 is .3. I can check here. If I go, oh, okay, so let's go to R3 while it says show IP int brief. As you can see, it's 155.1.1.3. So what I will do, .1.1.0 255 with the wildcard mask of 000 255 from this source to any. Permit 155. There shouldn't be any problem, but .155.1.1.0.000.255 any, and there is a problem here. Oh, sorry, I forgot to put the IP. Okay, permit IP. So from this source to any destination. So now I'm going to apply this on the NAT. So with the command ipnat pnat inside source list, my list is internal, so the list that I specified in my IP access list, and then I want to translate it to the interface gig 01, which is this interface with this IP, and I use the keyword overload because I'm using the path or NAT overload or port address translation. Okay, now I'm going to for example, from router 2, show IP into brief, and ping 155, the loopback interface, 150.1.108.2. Okay. When I ping this, if I go to R4 and show IP NAT translation, so I can see that the inside local is the IP address of this interface. The outside global is the loopback IP, and the outside local and as you can see, the inside global is the IP address which we use for translating the IP, and this is the outside global, the loopback IP address of the R4, the R8, the ISP actually, the ISP. So now if I go to the ISP, and as you can see, now it is coming. So I just ping again, and as you can see here, it is not showing the IP address. I'm pinging from R2, and R2 has 155.1.1.2, but as you can see, it is showing the translated address. It is showing this address. So it means this router 4 is translating the local IP addresses to 155.1.108.1, as opposed to the time that we didn't have NAT and we were just using the local IP addresses. So with this lab, I've showed you how we can enable NAT in the network. So this interface, NAT inside, NAT outside, and then the NAT translation is done on R4. So all the internal IP addresses are translated to the IP address that we specify for NATing and going outside. I hope this lab has been useful. Thank you and see you in the next video.